didn't find the switch button for the scene switch. Oh dear, that's a good start. Hello, and welcome to another scheduled stream. Hang on, need to check some stuff on the other machine here. Right, a bit early. I haven't had my coffee yet, so I'm gonna be slurping while coding and talking. But to get some things out of the way, I have now made the... I am not typing. Why am I not typing? Because... right. Apologies, my keyboard is still connected to the other machine. Like I said, not prepared. So what I did on my Ko-fi... Is it not Ko-fi.com? Oh, it's with an... Oh, man. There we go. This one. That's what I was looking for. So if you look at my Ko-fi page, I now made the GameBoy assembler Alpha 01, as I call it, available for my monthly backers. So if you subscribe monthly for as little as £3 per month, you get all the source code from every single stream that I'm doing. Well, that is, if it is worthwhile releasing, right? If I don't really get anything done in one stream, then I won't be releasing that source code, obviously. But I will make all the versions available to subscribers. Anyway, so I now have a license in here, some readme about the source, shows you how to compile it, stuff like that, all the things you need, and yeah. So, and I also have this little to-do in here. Actually, the to-do itself should probably go out of this folder. Hang on, let me do that real quick. So, we do this and put this in here. So, and what we're going to do, since this is Alpha 1 and has already been released, my favorite form of, source version control is just copy-pasting the folder and rename it Alpha 02, and then we work on this one. There you go. This is my way of doing version control. Very primitive, but here we are. Okay, let me quickly go to that folder, right? So projects, GB assembler, and then we have Alpha 02. We can still build, of course. Excellent. And we can still run, of course. Excellent. Before I go too much into the to-dos and what I need to do for today, I thought it would be good to, start with something like this. Hang on. Open a new tab. I hate this new Explorer, honestly. Oh well. So users micro sublime. So if you remember, I have this path pretty much hard-coded, right? It's looking for this GameBoy assembly file right here in this location, which is kind of insane. So I thought what I'm going to do today is just, oh god, copy this file, right? And we're going to copy it into this folder somewhere. Let's name it, I don't know, data, right? And then we have the program GBASM. So now we can change the hard-coded path where we look for stuff to just simply say data. Hello there. And if we build and run, it just works. So I thought if I share the code, I realized not everyone might have that exact folder, right? And it is hard-coded in there. I mean, you have the source code, you can change it, that's fine. But let's play nice and just make it relative. And maybe I want some more files in here. And also the good thing is I can just go into the data folder and directly edit it if I need to, right? Oh, the smiley here cracks me up all the time. It's so funny. Okay, never mind. Love a good go-go juice. Okay, anyway, so that out of the way, let's get cracking. So what did we have next? So I added a few more things, by the way, that I noticed after the stream while I was packing this stuff up. I have not changed anything on the code, right? I will try and not edit the code while I'm not streaming, so I will try to do this only on stream. Yeah, but I added a few benchmarks here. For example, I want to benchmark basic file read, buffered and unbuffered against file mapping, because at the moment I use file mapping. I'm not quite happy with file mapping. I know this is like the fancy new thing that everyone likes to use, and you know, they claim it's faster, but there's a few caveats with that. For example, you can't really allocate full pages ahead, right? So it just only allocates multiple pages. It only commits the pages once you actually touch them from a file. It reserves all the address space for you. That's fine. But as soon as you cross a page boundary, you kind of encounter a delay while it tries to commit a new page. And I'm wondering if I just, you know, commit everything up front, it probably would be faster, even if I need to do a memcopy. Memcopy is not really slow on modern machines, right? After all, a CPU is designed to do exactly that. That's like one of the main functions. Copy memory from A to B. That's like one of the basic things. So you can probably do that really fast to just read a file. So allocate a buffer at once and just read the file at once. And I think you can even do like some unbuffered reads, so it doesn't go over like, you know, over a kernel buffer that's like in between you and your program and things like that. But I have to read up on that. I haven't do too much reading on that one, but I'm fairly sure this is possible. And also file mapping. If there's an error happening somewhere inside the kernel with the virtual, you know, with the page table, the only way you can get notified by that is by some kind of exception that your program now has to handle. So now suddenly you have to handle like some obscure case, you know, that there might be something wrong outside of your normal program flow. And I don't like that at all either. So I much rather have, you know, program flow that I can reason about. So I'm just wondering if file mapping is really worthwhile. File mapping is probably very useful if you still do like, you know, only read certain chunks of a file from different threads here and there, then yeah, it's probably great. But in our case, we're passing a file from top to bottom all the time. Not sure it's really worthwhile using file mapping for that, but I mean, it is in there for now, so I'm just going to leave it, but I really want to benchmark it against the normal reading. Okay. And then there's a bunch of things here that we said we need to do. So think about rewinding or peaking at the next code point. At the moment, there's some ugly decrements of values going on in the tokenizer, which I do not like. That is correct. And then there's this stuff with error. So really, this is error handling, right? This is fixing the code point. Fix column overflow errors, that also goes into this area right here, right? Think about token buffers. This is like for token parsing later on, so let's move that down. Make column start at 1. Again, this belongs to these. So these three are grouped together, and then we have kind of like this separation of areas of concern. Let me switch those two around. So let's take a look at file reading, right? So where was I? Let's make this full screen. I hope everyone can read that. So IO source file. So the problem we had is that in the tokenizer, I'm sometimes doing things like this, right? I'm checking whether the current code point that I've read is a white space or not. If it is not, then we have reached the end of the sequence, but I needed to rewind the file read position to then be able to, you know, read the next token once I I go through this whole process again. Otherwise, we would be missing one character, and that's not great. But really, that should be not concern of the tokenizer, right? Why would I need to know about file columns and rewinding them and the line? And then we have some errors in there anyways, as you saw, like here, where we suddenly overflow, you know, and have a ridiculously large column number, which is not correct in any way. So let's just all make this concern of this source file stuff and think about how to handle this. So we still have the length and base. Let's switch those around. So the base pointer of where the source file starts, we have the overall length, we have the current position, the column, and the line. That so far is great, isn't it? So when we open the source file, yeah, this is fine. So then here position is 0, that is fine, but really column we want to start at 1, right? So the first character is the first column, and we are on line 1. Position is 0 because this is the overall byte position, right? So we want this to be the index, so we're starting from 0 there. Then we have close source file, which is also fine. I'm not going to care about resetting these. And oh, I actually do. Never mind. Didn't really have to, but that's okay. So code point is digit is fine. Actually, this is so small, we can specifically mark this as inline, even though it will probably be inlined anyways. Yeah, let's not bother. Let the compiler decide, whatever. Adding inline to functions was necessary before when the compilers weren't as good with optimization. So you kind of had to give a hint and be like, hey, please, please, please inline this. But nowadays, I mean, the compiler is also free to ignore it if he wants to, right? So sorry, I'm going to be sipping on coffee a lot. I haven't had my morning coffee yet, so this is it. Then we had this read code point from file. This is actually all right, right? End of file, as far as I remember, is just 0. Where is it? End of file, 0. Yeah, and then we have invalid code point, which is -1. That is fine as well. You know what? Let's remove this maximum file size because yeah, I don't care for that right now as well. Where was I checking this? Somewhere here, right? Yeah. Where is this used? Nowhere. Cool. That can't be right. I'm sure it's used somewhere. Anyways, okay, so we have this write source file error. This I probably will move out of here at some point and actually have a separate error handling method. I have kind of an idea what I want to do with error handling, but I'll get to that later. So right, so these are all okay. Is code point digit, yeah. So read code point from file, okay. Okay, I already advanced this position here, which I don't really want to do, right? So I thought I'd break this up into the following points, and that is get code point, right? right? Which will always returns the current cone point at the current position, right? Actually, it returns the cone point at the current position. So we're just getting that without advancing the pointer at all. And then what we can do is have an advance here, or maybe swallow, where we basically just, advance to the next code point. That will like resolve our whole issue with like having to rewind all the time, because now we're just reading the current cone point, and if it actually is what we want, then we say, okay, swallow this one. And then get cone point will, get the next one. Because here we're advancing the position. Maybe advance to next is probably a better name. Yeah. I think that would work. So let's read code point from file. Let's make this get code point. All right. We still need to pass in the file. If file position is bigger or equal to length, then we reach the end of the file. That is still correct. Then we get the current position. If it is this one, then just return, right? No longer advance the position. To be fair, I also don't really like this for loop here. I mean, you see why I did this, because of like the file length stuff. Maybe I leave it in. I mean, it probably will be unrolled anyways. Maybe? Can it be unrolled? Actually, probably not. I would have to look at the output, but... Okay, so then we have the new position. This is still fine. Okay, if we are too long, we return an invalid code point. That is also okay. Okay, and here we do not want to... Right. So what we really want is position equals file position plus 1, and then position, it's not great, but can always refactor later. Let's just get this working, and then I'll worry about anything else later. Is that correct? New position is kind of misleading as well. It is actually the end position, right? Okay, so this will get the code point without advancing. Now we need a way to advance. So void I'm wondering now, because, so there's two ways of doing this. basically could try and read it again, right? So I could do something like, what is this, S32, code point, get code point, right? I would have to pass in the file, obviously, but... And then I could figure out what kind of code point that is and then jump ahead as many bytes as I need. Or I can indeed make this a swallow. And then just do this. So then we just pass in the code point that we've already previously read in here. Let me check something quick. EUT of 8. There we go. This is what I wanted. So we can then say if code point is... Why is this an S32? Ah, this is annoying. Okay, need to have a special case for this, I suppose. If code point is smaller than hex 80, right, because the last code point for 1 byte is this, then we only advance like 1 byte. Then if code point is smaller than, so this would be 800, right? Else if code point 0x800, 0, I assume? Nope. Okay, completely flew out of the window. Well, I guess this one, right? And else he thought he saw a pattern, but he did in fact not. And this is the last valid code point, right? So we can do this. Yeah. Okay, and oh, but we also need the file, right? So that doesn't go away. Right, so file and position would be ++, right? And here file position is +2, file position +3, and this is file position +4. let's make this an early termination case bundled together, right? So if it is smaller than 0 or it is bigger than this, then that is a no-no. And then we do this. Right, that's our correct intent here. And then column itself, we just increment by 1 because, well, it's just one character, even though that's not entirely correct as well, because we're not accounting for combined characters, right? We can have multiple cone points together and that forms a character, but we're not going to go that deep into like parsing this stuff. We don't really care that much. The only thing we need all of this for is because we want to allow for, let's say, Chinese characters as label names, right? And we do not necessarily care for the right, right combination of characters because we never display them onto the screen. All we're using that for is taking all the bytes anyways, and actually as UTF-8 encoded bytes, and just use them for the hash table, so we can find symbol names again. So this is really just used for validation while reading to see if the file is actually correctly encoded or not. That's really the only purpose of all of this. Okay. So this will get the current code point on the position that we're at. And then we can swallow that code point, which means we advance the position and we advance the column, right? But once we advance past that, we also want to know whether this code point was actually a white space, no, not a white space, sorry, a new line character or not. And then increment the line count as well. So if code point is new line, then file line ++, right? Because now we're in the next line. We're reading past the new line character. But then we also had this with new line right here, right? Okay, so let's just copy this code because this is already something that we did. Plonk that in here. So if the code point is a new line, we are checking if it is a CP new line CR, so code point new line CR. And on Windows, CR can be followed by an LF, right? So we want to account for that. So we have, so we're reading CR, that is the current code point. Right. So here we already have advanced the position and we want to read the next code point. So we can say get code point. Wait, I still need to pass file, of course. S32 next, right? Actually, no, we can't do that here. Okay, I have to think about something here. I thought I could recursively call that, but then it would still count the new line as twice. That's not correct. Oh, brain, start working. Maybe more coffee will help. Hang on, if it is LF, we know we just need to advance 1 byte, right? So file position plus plus, right? It's just 1 byte. It's an ASCII character. What am I worrying about? Why would I swallow code point again? Okay, so we're getting the code point. If it is LF, we're just gonna swallow it, which means we're going 1 position further. And regardless of that, we count that as 1 new line, and then we reset the column, but we reset it to 1, because we want columns to start at 1, right? If it is not a new line, all we do is advance column by 1. No, we've already did that anyways. Okay, now let's remove that. Yeah, okay, I like this. This is alright. Okay, what about failure points? Do we care? Nope. We just return. Again, I want to change the error handling a little bit, but I'll get to that in a moment. Okay, so we have swallow code point and we have get code point. Write source file error for the time being stays the same. I'm not going to touch that. And then we have is code point valid, right? So this makes sure that we do not have any other control characters. It can be some of these. We skip these control characters as well. Those are not allowed in the source file at least. Right, and this was the thing that I combined read valid source code point. So this is so if we have an invalid code point, we can actually just exit the process and be like, nah, this is rubbish. We don't know what this is, right? But now I'm thinking, do we even care about this, right? I think what I would do is just okay, I have to talk about my error handling idea. So what I thought to do is instead of like, you know, terminating the process like in these functions whenever we have something invalid. So all of these read valid source code point, right? If it had an invalid code point, it would just terminate the process. It would just exit it. And it's kind of hard to reason about it when you go through the code. You're like, hang on, can this function actually just terminate my process? Or, you know, is it just going to play nicely and it cannot fail and things like that? So that when I thought about it the other night, it felt a bit wrong, so to speak. So what I would rather have is allow for all of these functions to still continue execution even if I have an invalid code point. And we're just going to treat it as an end of file. An end of file will basically just, on the next go through, just stop the whole parsing, right? But then how do you convey to the user that an error happened? Well, I thought in general, because sometimes in parsing, if you cannot resolve a symbol or something like that later on, you still want to continue parsing the whole file, because I would like to print all errors within the source file back to the user, not just one error and that's it, right? Although in terms of an invalid code point, that will definitely just print only one error, because that is a serious error, right? So basically what I was thinking would be nice to have like a global arrow log, essentially. Just think of it as a dynamic array that grows, where we can put on error messages, one by one. And it just grows and grows and grows. And at the end of the file, so somewhere around here, so after we went through all the tokens, we can then just check, are there any error messages? If they are, print them all out to the user, right? And yeah, that's basically it. So I definitely still want to be able to report that. And I think how I'm going to do that is, so instead of returning invalid code point, what I actually might do is to do add an arrow to the global error handle, or arrow list rather, right? And then we're just going to pretend we have reached the end of the file. But I also have this whole thing, right? I mean, whenever I get a code point, I definitely check whether it's valid or isn't, right? I do that all the time anyways. So why not do this, right? And then here say, right? By the way, this is false can also just be written like this. It's just, I find sometimes the negation a bit, hard to see. So I made this little macro, which is like, bam in your face. And then say result, right? I'm trying to think if I can void all these early returns here. So it all just flows naturally through to this point, so I don't have to duplicate all the code. Let's try. Famous last words. Okay, byte is only needed here, where we first read it. And then can do this. And then we just say results equals byte, right? And then all of these just become an else if. Oh dear. Right here. No, the to-do still needs to be there, so we still need to put an error here, but result equals end of file, and the end position can just be that. Okay. So now we're flowing through. And we still want to check this. Yeah. And then result equals end of file. And what we probably want to do is set end position to file position again. And then we can just go to the for loop. And this will be file position +1, right? And position is smaller than end position, which can happen in all of these error cases, right? Because it is just the file position, and now we're one ahead. So we will never go into this for loop at all. And then here, instead of return, what we're going to say is result is end of file, and we're just going to break out of the loop. And then we can check if code point is valid, right? And in an error case, this will be 0, so it will be rejected right away. It is not valid, in which case well, we can make a quick check, to be honest. So if results is end of file, then we just return end of file, right? No, actually, let's do it this way. So if we have an end of file, we just return the end of file. We no longer need to report any invalid error codes because we've already done that up here, right? So there's error messages here, like very specific error messages, because that is an encoding error. And then down here is actually valid code points, but we do not allow them. So then we just can say, well, we need to report it here. And then just do this and return. Okay. I drank all my coffee. Damn. I'm almost debating if I should get a new one, but then that's too much caffeine. So water it is. I can probably make this a bit nicer as well, to be honest. Like, I'm sure if I think about this a little bit more, I can tidy this up a bit more as well. So I maybe don't have to report all these errors. I mean, nah, let's not bother with it. Let's just make sure this works, and then... Okay, so now we have essentially combined those things, and when we get an error, at some point this will just report or add an error to the global error handler, to the global error list. But it will just return end of file, right? So all the parsing code can just continue with its normal execution. So there is no need for like this stuff, which is nice. So now, ulan, white space, and digit. Yeah, we still want that, but we're gonna remove this thing right here, and all we're gonna have is get code point and swallow code point. And now, because I don't have this whole negative thing, you know, of like this one, invalid code point, right? It's no longer used, so I'm wondering if I should just, instead of S32, just make it a U32. Which maybe is not a bad idea. Yeah, let's change that to a U32. Right. Let's check that we didn't screw anything up. So this is still okay. I mean, these definitely will still okay. Yeah, so this will wrap around, which is good. Yeah, actually, I didn't account for overflow with the signed into. Ah, that was bad. Okay, this is definitely easier to reason about now. It can be smaller than this. Yeah, that is still okay. Right. Let's see, results. Yeah. That is still, what is byte? Byte is an unsigned 8 anyways. Okay, so that just works. Yep. Yep. Yeah, all right. Cool. Now we just have to use it. Okay, so read whitespace sequence, right? So now, brain, I already forgot. It's just get code point. Okay. So we're getting the current code point. We don't need to remember the position. We're just getting the current code point. We also no longer have an arena, right? So it's literally just the file pointer. And while it is not end of file, continue. So if this is invalid, it will just hit end of file, and then we'll just pretend it's an end of file. Okay, cool. So if it is a white space, right, then we don't need to do this. Did I have a typo? Cop the point? What? Yeah. It would be nice if I know how to spell code point, right? It would help. So we no longer have to rewind, right? So what we can do is, if we do indeed have a code point that is a white space, actually, If it's not end of file and it is a white space, then what we're gonna call is our little swallow code point. Right. There you go. I think this is a bit nicer now. No longer have to worry about like rewinding and positions and stuff like that. We literally just get a code point, check if it is what we want, and if it is, we swallow it, which will advance the pointers. I think this is cool. Don't know about you guys, but I think it is. So get code point. No longer need an arena. Actually, we can remove the arena here, which is so nice. This is what I wanted. Because again, the arena was only used for error messages, which is bonkers, right? I really just want to pass an arena into something when I know it's going to allocate all the time, right? If it's just for an error case, then yeah, let's not go that far. Okay, so whoops. So if it is not an end of file, right? Okay, this is the end of the token. A token can only end with a new line, or with a white space, or with another token, right? I don't really want to cram this in all in one line, but so if it is a new line, or it is a white space, or it is a token, then we return. Otherwise, swallow code point. Yeah. Read end of line. Probably also doesn't need an arena anymore. We don't need this. Then we just say get code point out of this file. And is false. So if it is not a new line, we just want to continue with this loop. Should I do it like this? Nah. I have screen space. It's fine. Stylistic choices. I love how small this now has become. That is cool. So if it is not an end of file and it is not a new line, and we're just gonna swallow. Okay. Cool. End of string. Also, no longer need a memory arena. We're calling get code point with a file. And if we're not in the end of file, we just continue, right? Then if code point is new line, then we want to stop. So let's just stop. Actually, oh man. And And it is not a new line. Okay. Now, if code point is this, then we want to, well, in any case, we want to advance, right? So swallow code point. Right? But if that code point was this, then we're calling get code point right here, which is the next code point in line, right? And then we're checking if it is an end of file. And even if this is an error, it will return an end of file, and we just pretend this is the end of the string. Perfectly reasonable, right? If it is not an end of file, we probably want to swallow that code point. Because we don't just, yeah. And if it is a quotation mark, then we're just returning because we found the end of the string. Okay. So now read token. We probably no longer need the arena. Yep. Cool. We just need the source file and the result token. So this token is at the current file position, at the current file column, and at the current file line. That is absolutely correct still. And then we just want to determine the token type and the token length. So we're, I just realized I have not changed this to a U32. Yeah. Same here, U32 now. Get code point, no longer an arena. If code point is end of file, the token type becomes an end of file. Cool. If the code point is a new line, we have a new line. I just realized something. Because if we pass in end of file, we also don't want to advance the file pointer anymore, right? Because we are at the end of the file. Wait, and the smaller doesn't make any sense anymore anyways, so... because it's no longer signed. Okay. So code point is 0, or it is bigger than max code point, right? Then we don't do anything. Otherwise, we're going to swallow. Okay, cool. Probably need to do swallow code point now, right? Because this is valid. This is valid. Then read whitespace sequence, which will swallow for us. Read end of token will swallow for us. Read end of line. I think in this instance we just want to swallow anyways. Right? Yeah. Yeah. Because all of these start on the next. And file position is before that swallow. Yep. And then I have the token length. Okay, cool. So this should work. Famous last words, right? So let's see here. Retoken no longer needs an arena. We just need the source file, and otherwise the code should still be fine, right? Build. It is not fine. Okay, so source file line 210 byte is not recognized. Well, yeah, that is indeed true, because we moved it now. Is that a bad thing? I mean, it can just be like whatever, right? Okay. Get code point undefined. Oh, because I still have this with the error here. Yeah, that is correct. Oh. Right. Swallow call point still needs the file, obviously. So file. No? What did I do wrong? Oh, I didn't change this. Right. Okay, there we go. Arena, undeclared identifier. Possibly? Oh, yes, I haven't removed all of them. Okay, end of string. Yeah, there we go. There we are. Nice. And we also seem to have fixed the column error right away. We're no longer overflowing. Cool. But let's see if that actually makes sense, right? Let's clear the screen and run. So lines 169 is still correct, I believe. There we go, 169. Cool. We have actually read the right amount of lines. And then let's see if the columns work right. Right. So we have a comment at byte position 0. It is 5 long. Yeah, because there is this little thing right here, right, which is 1 byte, and then the smiley, which is 4 bytes. It is on line 1. That is correct. And it is column 1. Well, it starts at column 1 at least, right? The comment, it just shows you the start of the comment, and it starts at column 1. That is definitely correct. Then we have a new line character, which is like right after this, right? We just can't see it. Well, I mean, we can see the new line, obviously, but new line is at position 5, yeah, because this is 5 long, right? Starts at 0. So from yeah, from 0 to 4, right? And then position 5, yeah. Length 2, yeah, because we have CRLF line endings, so 2 bytes. It is still on line 1, which is correct, but it is column 3, which is also correct because we have column 1 is this thing, right? And then this is column 2, and then column 3 is the line ending. Cool. So that seems to work. And then let's look at the next comment. That is right here. That is position 7, right? That is the absolute byte position. But it is, in fact, on line 2. It is on column 1. And the length is 17, which probably is correct. Yes, 17 characters selected. Cool. Nice. Huzzah! We fixed errors. So think about rewinding or peeking the next code point. That is done. Fix column overflow error. Done. Make column start at 1. Done. Bam. Okay, display overall runtime of the assembly process. Right. So I thought it would be nice to have like some statistic output at the end. So after you've compiled or assembled all your source files, right, it would be nice to see how long it actually took to assemble all of them and how many lines of code, of assembly code, have been processed, and maybe how many files in general as well. I'm not sure about that one yet, but something like that. Sorry, I had to check something on the other screen. Yeah, so let's do that. Let's time the runtime, essentially. I mean, I don't have to go too hard on this because, like, at the moment we just have one file, so I can just put everything in here. That's probably okay. Let's put this in base. And what do we call this? Stats, statistics, stat. Maybe not in base then. Parsing, because we're measuring the parsing, right? Maybe that. Yeah, let's put this in parsing. Nope. Yeah, that is not the file name that I wanted. Stats.h. And then we can probably have stats.c. And then down here in main, include parsing stats.c. Why don't you switch to a header? Nope. I thought you would automatically recognize header files. Weird. Okay. So what kind of stats do we want? Type def, struct, parsing stats. Right, and then struct parsing stats. And what would we like to know? So we probably have a start time and an end time, right? For that, we can then do calculations that we want to. We have overall lines processed. We have file, actually line count, right? We have file count. Let's call this start ticks, end ticks. Anything else? Not that I can think of at the moment. Nothing that would be interesting. Nah. Okay, and then we can have parsing stats. On the memory arena, right. Probably put this on the stack, but like I said, I kind of want to avoid stuff like that on the stack because it might actually grow, and so we'll see. And again, I forget how to use my own stuff. So get memory arena buffer, right? We want the arena and we want the size of parsing stats t, right? And parsing stats t stats there we go. Could probably make a macro for this, to be honest. Because I see that probably happening quite a lot. Where I have to specify the type of something. Nothing I need to worry about now, but okay, but how do I deal with errors here, right? So studs is null. That can definitely happen. I probably want to well, at the moment I can just probably exit the process again because this is like a memory issue, right? So let's just do that. I really have to change that. Okay, those are parsing stats, and then what we want, okay, this probably should not be in the header, right? Should be in here, but we definitely want the definition to be in the header, so let's put that in there. And then what do we want? We probably want to print those stats, right? And we also want to start those stats. So, to be honest, we can probably start with time measuring in here, right? So line count is 0. File count is 0. And then antics is 0. And stats, statics, well, get ticks, right? Whatever that will be. And for that, I do have something that I did for a video once where I did some benchmarks for command line tools. So let's go into the benchmarks. Nope. Where did I do this? Common. There we go. These things right here. That's what I need. Let's remove the inline, let the compiler deal with that. I'm not sure if I really need the US timer, to be honest. Oh no, I do for timer frequency right here. Okay. I remember there was something else I had to do, right? Frequency. Yeah, I probably should store that as well in the stats. Frequency, right? And frequency will be this. And then statics will just be read CPU timer. So this is using an internal CPU counter, RDTSC, right, for the timestamp. And then at the end, I use a fenced RDTSCP. And that basically gives you, it's a counter in the CPU that like counts upwards in a, how do you call that, monotone fashion? Monotone, I don't know. English, hard. It basically just counts up for every cycle, I think. And you basically can figure out with this your CPU frequency and then how long some piece of code actually ran. So this is like usually used for like benchmarking and things like that. And I have used this for benchmarking before. I'm explaining that very poorly at the moment. I'm sorry. But yeah, I thought I did some other stuff for the benchmarks as well. I thought I had like some fencing in there. Maybe not in this one. But where did I do it? I remember doing it. Definitely wasn't in the header extractor. Did I do it here? No, here I actually used memory fences. Wait, what is that? Sorry, I know I'm getting distracted right now, but that's not an intrinsic, is it? That would be weird. Apparently it is. Okay. If I do remember correctly, it is like good practice to use it with a memory fence, but I'm not quite sure. Hang on. No, we want this one. Right. And then what does this actually return? In 64, so of course it's a U64. Jeez. Okay, let's do it this way. I really have to read up on this again. But in anyways, we can start the CPU timer like this, and then in the end, what we can do is print out all of our timings, right, and all the statistics that we have. Although the stats increasing line count and stuff like that, I have to see how I do with this. But in the end, basically what we want is print. Oh God. Parsing stats. There we go. Do we need a memory arena for this? Possibly, because we probably want to allocate, enough memory for the messages, right? And what we also want is the parsing stats t. stats. There we go. And then we want an assert for stats to not be null. There we go. Okay, let's print. Right, I have the string format somewhere. Hang on. String format. There we go. This is what we want, right? And this is our message. Pass in the arena. And then we have our string format and then the actual values. Okay. So, what we want our message to be. Done in... I don't know what to use here. Let's just do /d. I'm sure there is... Hang on. There is something in stb as printf for like times and stuff. Let's read the documentation. No, so see, I thought it was like something like this, because it has like modifiers for kilo, mega, and giga and stuff like that, and I thought maybe it had something for time as well. But apparently not. So I remembered wrong. But that's okay. What did I do actually in the benchmarks? I already printed it out, like, so. Nope. Where is a print? Sure, I had to print out print result. There you go. Where do I find you? Print result. There we go. Cool. Right. Oh, I printed it in cycles. I can do that. Yeah, let's do that. So first, %f for floating point, right? We probably want to limit it to 2. And then let's just say s for seconds. And then we can also print out the cycles. And then this many lines across this many files. That seems okay, no? Okay, so what do we need? I wonder if print parsing stats should stop the timer or if I stop it manually earlier. Let's make it explicit. Let's name this start new parsing stats, right? And then stop parsing stats. And assert stats is not 0, right? And then we can say stats nticks equals read fenced CPU timer. So this will be inlined anyways. And then in here, what we need to do is have, let's say we have a double, and we call this runtime. And then we have stats, start ticks, right? Actually, let's make this separate variables just for this, you know. Let's just call this ticks, right? We have stats nticks minus start ticks, right? I mean, we could check if stats nticks is 0, right? Then what we probably want is to say stop parsing stats, right? That's probably a good way to do this. So we want the overall ticks. So again, this is just a counter, right? This is not a time. It just basically counts the amount of cycles an operation took. So we're getting the start ticks, which is how many cycles have happened since you booted your machine, right? And then you basically just continue with your operation, and then in the end you call the same timer again to get the current tick count, right? Which means, again, how many ticks have been advanced since you booted the machine. And then you just subtract the old one from the other one, and then you know how many ticks, how many cycles your whole program ran for, right? And then you have to translate those ticks into an actual runtime. This is what we're doing here with read CPU timer frequency. All this is doing is it's getting information, roughly, it's only a rough approximation, right, of how many cycles my CPU can do within 1 second, right? And then, because you have the frequency, you can then divide those ticks by the frequency, and then you know how many seconds your program ran for. It's pretty straightforward, I think. Well, so what we want to do is say double ticks divided by double stats frequency, and that gives us the runtime. So now we can pass this in the runtime. If we also want to know the cycles, we just pass in the ticks, right? That is the amount of cycles it took. This percentage here, this is from STB, so it will actually convert this large number to like mega or giga or however long, something like that. Then we want to know how many lines we pass, right? So this is the line count, and then stats file count. Okay, and then we want to write this message out into the console, which we can do here. Message, right? At some point, I'm going to make this some compiler, a command line flag for the tool, right? Because you maybe don't want to see the output, but it is quite useful to have that while we actually, while I'm developing this thing, just to see how long things take and if I screwed something up badly or whatever. Okay, so, and then that's all that's left to do is, hang on, bear with me. So we want this, right? And we want print. There we go. And I mean, we can measure open the source file as well, because if we have include files and stuff like that, we also get that into the runtime. So we want the overall runtime. And so new parsing stats, the arena, and we have parsing stats t stats, and hey, thanks for the follow. Oh, apparently I had a follower goal. Well, yay. I'm still learning C++. I can barely understand this because I'm still a newbie. What is the objective of your program? Okay, so the objective of my program is to build an assembler for GameBoy ROMs. Now, an assembler is basically a form of compiler, if you want to say it that way. But basically, you have like this source code right here, right? So this is assembly source code. Assembly is basically just machine instructions. In this case, machine instructions for the Game Boy. And what you want is parse this file and spit out a binary file at the end, right? So just basically a Game Boy ROM. So you can load it in an emulator and then actually execute this code, or actually put it on a cartridge, put it in the Game Boy, and run it there, right? So basically, I'm building a translator for assembly machine code into the actual binary, so to speak. That is the objective of this program. And I mean, don't worry if you can't understand stuff. I mean, if you're just starting out, that's pretty much normal, right? Don't give up. There's lots to learn. Programming is by no means easy, so don't get discouraged. That's the only advice I can give, really. You've done some open source correctness. But yeah, that's basically it. Yeah, you have a binary, you have assembly, and the high-level programming language. Yes. So high-level programming languages might actually compile down to assembly and then compile it into binary, or they might just skip the whole assembly step altogether and just use high-level code and some other representation of their code internally and then just spit out the binary. Depends. Okay, so where was I? Okay, we have the stats. New parsing stats. No, I renamed this, didn't I? I renamed this to start new parsing stats because we're also actually starting the timer. So, and I do not need to call stop because that is called down here because ticks will be 0. So I'm just going to call print. Yeah. Okay, so right about at the end, let's say after we close the source file, so we can get rid of this message right here. And then just basically say print parsing stats. Well, and we also need a memory arena. Okay, fine. I might want to switch around the argument. I always want the arena first, so I know, hey, this thing is allocating, right? So let's also need to change it in the C file, I believe. Oh. Okay, so now if we build, it cannot open a file. That's a good... What the... What is status? What? What? Stats. I cannot... Wait, why did it not rename? Rename? There we go. Okay, cool. Now we actually get other errors. Right. Because I'm dumb. This is start new parsing stats. There we go. Okay. So now if we run the assembler, it actually shows done in 0.09 seconds with, what is this? 331 million cycles. 0 lines across 0 files, which of course is not correct because, yeah, we haven't done any of the statistics yet, so we need to do that. What we can do is before we close the source file, basically we can just say stats line count plus equals source file line. Lines? Line? No, line. Yeah. And... well, we know we at the moment only have just one file, right? So you can just say file count plus plus. Right. There we go. And now if we build and run, yeah, it is a high number. Oh, sorry. I'm not sure if it's million. Yeah, whatever. So we have 169 lines across one file. One files. Right. Now, that's nicer. Oh, we should probably do that for lines as well. If we just have one line. Not sure why you ever would, but, you know, you never know. Hey there. My dog is being restless. Come here. Come here, come here, come here. Say hello. You want to go to the bed? All right, there you go. Okay, so I'm happy with this. This is quite cool. I'm not sure if the cycles are really useful to display. Honestly, probably they are not. Don't worry, stupid is my game as well. So, you know what? Let's just remove the cycles for now, because like we're not benchmarking or anything like this, right? This is just a small message that I want to just display. Basically show the runtime. There we go. We just care how many seconds roughly, right? 0.08, 169 lines across one file. Cool. Another thing of the to-do. Okay, remove memory arena from tokenizer as it is only used for error messages. We actually have done that already. But I'm going to replace this with implement global error lists, because that's what we need. I'm not going to worry about token buffers right now, because I actually have not thought about it. Let me also add think about error handling on arena allocation failures or general Windows API failures that indicate fatal error. Okay, so time for the global error list, right? As I said before, I do want to design the code in a way that it's just being able to continue with execution even though something went wrong. What does global error list mean? Yeah, I'm going to explain that now. So I want the program to be able to continue execution, right? Let's say, for example, you have a symbol in your assembly file that's not recognized. Actually, let's open this, right? So let's say you have, I don't know, wait for v_2 and it's nowhere defined, right? You still want to continue parsing the rest of the file and just display all the errors that happened while parsing back to the user, right? And I do not want to handle like specific error return codes, all this kind of stuff. My only return will be, just go to the next token and continue parsing from there. Or if it is like really something serious, like a code point or the file is corrupted or whatever, then we just pretend it's the end of the file, right? But we still want to indicate that an error happens. So I thought, like, let's just have a global dynamic array somewhere, right, that I can add new items into, and those items being basically error messages. And those error messages will be things, will be the message, so of the error that actually happened, or warnings, or whatever you want to add, right? Some informational stuff, I don't know, like, anything really, like, I don't know. You use the constant here, right? Why not use a label instead to, I don't know, like informational messages, basically anything. So then by the end of parsing everything, Yes, a vector, but a vector is C++. This is C. We do not have a vector. So basically what we're going to do is we're going to implement our own vector. Hooray! So yeah, and then the error messages also have to have some extra information. For example, like which file did the error happen, which line in the file did the error happen, and which column in the file did the error happen. And because I like doing that, also which byte position, right? And I think this is something that belongs in the base. So let's put that in here. And what we're going to name this is going to be error.h. Why not? If endif GB assembler error.h and if. There we go. And then we also have a C file, of course, include error.h, and this will be our error.c. And then what we do is down here in main, after console, well, yeah. So we're going to do include base error.c. Again, I like to include C files in the main C file because I just like to have one compilation unit. Having multiple, to compile multiple C files is a bit messy, and then you have to wait for the linker to actually put everything together. So I just like to have one compilation unit and just include all the C files into one. It makes builds slightly faster, and I only need to specify one C file as a source file right here. Now I do have a second one, which is for MSVC no CRT, which is a kind of a special thing because I'm not using the C standard library and runtime. I'm doing everything myself, more or less. So I had to just provide a few implementations for like memset and memcopy and like this weird thing, so floating point calculations would work, which was fun to figure out. But okay, so error. How do we start? I think let's just start with an error entry and how that would look like, right? So whoops. So we have an error entry, and what really do we want to store in that entry? Well, we have a string that we can use, right? And that will be the file name. We want to know where the error happened. Then we want to know on what line the error happened. We want to know on what column the error happened, and we want to know the byte position the error happened, right? And then now I realized one issue with this, and that is, no, that's fine. Never mind. Ignore me. Then what we want is a string, which is just gonna be the error message, right? Actually, strictly speaking, not necessary to carry these around because we can just also encode that in the error message. But then later on, we might want to, you know, I don't know, like, if I'm thinking of ever making a UI for this stuff and things like that, right, it would be useful to like have this encoded like so you can then actually jump to the line if you needed to and things like that. So you don't have to like look into the string and finding the line number. But I mean, you're not really sidetracking at all. So, sorry, I'm just reading what you wrote. Yes, basically. So, I mean, okay, if you want to know, I mean, what is a vector? It's just basically a dynamic array, right? So, let's just do this. So what you would do is, let's just say you have the C library available. I'm not using the C library, so you would do something like malloc, right? And then whatever the size of the type is you want to store within your array. So in our example, it would be the error entry t, right? And then you give it a size in the beginning of how many elements you would expect at a minimum, right? So let's just say 8, for example, right? This gives you the array. So error entry t, call it vector, whatever. Sorry. So something like that. And then you would also have to, you know, remember the position of how many elements you have already stored in the vector and probably the length as well. So you would have length, right, which in this instance would be 8, and then you have u64 position. So how many elements do you have actually written into the array? And then you can just say something like vector position, right, if you want to add a new element. Like you would add it here, right, whatever the struct would look like. And before you add any element, you would basically just check if position is bigger or equal to length. And if it is, then you can just say vector realloc, right, size of error entry t. No, actually, yeah, times length. And then you just double the length, basically. So times 2. So now you have made room for 8 more elements, right? Until the vector gets full again. And then you double it again, and then you just grow and grow and grow, basically. And you can obviously wrap this all up in a separate struct as well. So, but yeah, I'm not using the C library, so I don't have malloc or realloc. I could use the Windows equivalents, right? So heap alloc, I think, and there's some extra parameters right here, but I don't remember them at the moment. And there's also heap realloc, I think, realloc or something. Is that actually a thing? I think so. Yeah, there you go, heap realloc. I mean, there's some extra flags and stuff, but it basically boils down to what I just wrote. But I'm just going to be using my memory arenas. Memory arenas are essentially the same thing, except they use virtual alloc and things like that. So I'm actually reserving a certain amount of address space of what I expect this to be, and then I'm only committing like 1 page of memory at a time. So, I mean, I'm doing this at the start of the program here. So I have a commit size of 4 kilobytes, right, which I know is the page size on my computer. And then I have a reserve size. So I'm reserving 8 megabytes of space, of address space, but I'm only committing 4 kilobytes. And that is stored in this memory arena right here. And then I can just write into the memory arena. And if it ever exceeds 4 kilobytes, it then commits another page, and or however many pages it needs to fill like the buffer. There's some more details about memory arenas if you're interested. So this dude right here has written a good article on like the arena allocator and how it works. Actually, I can drop the link in the thingy. Hang on. I have to do this on the other PC though. Nope. Oh, god damn it, Mac. Sorry, my other machine is a Mac, so all the shortcuts are different and it trips me up every single time. I'm using a Mac as my streaming machine, actually, and then the Windows machine to code stuff. But yeah, basically this article here is fairly good if you want to give it a read. It goes into a lot of detail, actually. Okay. Alrighty. So error. Okay, so this is the error entry. Again, these probably not needed, but let's just leave them in. I can always strip them out later on if I really don't do anything special with them, right? But then we want our dynamic array, so to speak. So let's call this error list. Struct error list. And how does a memory list look like? Well, we do have, well, a pointer to the first error entry, right? And then we have the, well, I do not need to worry about the amount. We just have a count of how many are in the list. Maybe I do need to worry about, I thought the arena would take care of that for me. Hang on, how would I do that? No, I just need to, yeah, the arena makes that easier. So I just need to request one item at a time. So if I need a new item, I just request it. And then if I only use an arena for this error list, they should be guaranteed to be in sequence. But I mean, instead of worrying about the count and everything like that, I could maybe just pretend like it's a linked list, but it's in sequence anyways, so it's fine. I don't know. Trying to think of the best way to do this with arenas. In any case, we need a memory arena here. Okay, and let's say I'll definitely need this. So let's say I say add error, right? Yeah. Okay. Let me copy the same syntax as I had here. Right, we do not need to specify this. And we also do not need to specify the struct itself, because that will just be a global. So what I have is basically error list t g error list, right? So this will be the global error list. At the moment, let's just make it null, but I will have an init right here. Right, something like this. That I basically would just call at the beginning of the program. And then we can just call add error from anywhere. And we accept the format. And we will be... Oh, I already copied this. Great. Good stuff. So format should not be null, and the G error list should not be null, right? Then we're getting the argument list from the format we pass in. And then we can just call string format list. And what we're going to pass in there is the... Well, that's the thing, isn't it? I essentially need an arena for the items and for the... I don't like this. Yeah, maybe just make this a linked list, to be honest. So I can store the formatted string into the same arena as the items itself. Yeah, why not? I mean, it's just an error list. Who cares, right? Okay, so I'm calling string format list, and I'm calling this on the G error list arena. Calling format with the args. This will give us a string result. And right? We're not returning here. So what we want is an error entry. Actually, the entry itself can also be in the arena, right? So let's do that. Get memory arena buffer. This will be the gerrorlist arena. And it will be of size of error entry t, right? And this is now the second time I had to do this, so I really should have a macro for this, so I don't need to type it out. You know what, let's just add one real quick. Helper macros. Define. Arena, and then the type. Right. So get memory arena type. So this is this syntax right here. So what we're having is type, and it's gonna be a type pointer. Right, and then this will be arena. Okay, arena pointer. And size of type. Maybe, I don't know if I like that. Sorry, I know my chair is really squeaky. I'm not going to overthink it too much, but basically what we now can do is do something like this, get memory arena type, and then we just have this like so, and then we just specify the type itself, right? So error entry t. There we go. And I use this somewhere else as well, I think in stats. Yeah, so this one can be changed as well. So this one can just be this, arena, and then parsing stats, right? There you go. Okay. I mean, yeah, I'm not done. I have a lot of errors here. That is correct. There we go. Stat C, what? Eh? Did I screw up the macro? Most likely. Type. Get memory arena buffer. Arena pointer. Size of. Type. Oh. Nope, still not. What? I don't understand. Is it because I surround the type by... No, why would that matter? Okay. Really? Okay. Fine. Fine, fine, fine. Okay, back to the error list. So add error. We get an error arena type because we need a new entry, right? So we want to put this into our arena. There we go. This is the entry. We have args. This one. Yep. We have result. We put this afterwards, which is fine. And then, so this doesn't need to be result. What this becomes is entry. And this will be the, let's just call this message, right? Message. But we also want strt file name. We also want the line. We also want the column, right? And we want position. Or, I mean, if we add the error, it usually... Oh, no, it can also happen with the token, right? So it's fine. I will make convenience macros for this. Okay, so file name, line, column, position, and then we just add those to the entry. So file name equals file name, entry line equals line, entry column equals column, and entry position equals position. Cool. And then we set the message, right? We probably want to... Okay, so this is the most important one that we need to check, right? So let's do that first. And then we also want to check that file name base is not null. And file name Do we care about the file name size? No, we absolutely do not care. Yeah. Okay, so this is fine. We have successfully created a new entry, right? We have added the message. We also formatted the message with some space after it. So essentially what we now have is like the entry struct here. And then afterwards we have the error message right there, right? So this is our memory layout. And then we'll have basically multiple of those. Like this, right? So now we just need to find a way, because those error messages are like in variable size, find a way to go through all of this, right? And one way to do this would be to say, so an error entry itself probably wants to point to the next element, right? There you go. And then an error list wants to point to the first one, which is the base. And then it probably also wants to point to the current one, so the last one added, right? We can still have an error count. That is fine. It's probably worthwhile printing that out later at the end. Okay, so what does that mean? Right. So if G error lists I mean, let's name this first and last. That's probably a bit clearer, right? So if first is null, then we just say, well, the first element is actually just our current entry right here, and de facto our last entry is also this entry, right? And entry next is always 0. Okay, but if first is not null, then we can be pretty sure that last is also not null. So what we're just going to do is last next is entry, right? And then we say last is also entry. I'm skeptical, but it should work. Okay, so how do we initialize this? Well, we make sure that GErrorList is null in this instance, right? We don't want to call that twice. And then we're just gonna get a new list, right? Actually, why I'm doing this so complicated? So this get memory arena type. Right, we do not have a memory arena yet, so we need to create a memory arena right here. Create error memory arena, right? For that, I'm just gonna steal what I have done here. Now I'm just gonna use the defaults, but you know, this basically later needs to be adjusted to like something a bit more sensible. Actually, 8 megs might be a bit too low. You know what? Let's do a gigabyte. Just because, like, during development, I will later adjust this to like smaller sizes, right? But we can go as large as possible. Let's just reserve a gigabyte of address space. I mean, we have tons of address space available on this machine anyway, so I mean, on any machine really. Virtual address space is huge. Okay. So an error list will essentially have its own memory arena. That is okay. I mean, this is what memory arenas are for. We can have multiple of those. That is absolutely fine, right? So we have a memory arena right here. I'm just going to use the default ones for now. If arena is null, we should probably do something, right? Actually, what am I doing in the... I just exit the process. Fine. Let's do the same for errors. Oh my gosh. Okay, there we go. Then we just use that arena to allocate our error list, right? There we go. Now we have a list stored in that arena, and this list will reference that arena, which is fine. And the first is 0 and last is 0, right? And then count is also 0. I forgot about count, so and also what happens here, right? If entry is null, basically we can just increment the count here. What happens in string format list? Oh, if it fails, it doesn't care. The message is just going to be 0. That's fine. Cool. Yeah, that's absolutely okay. I don't really know if I want to actually exit the process if the entry is 0 here. To do, probably do not do this, right? But I don't know yet. Okay. Then we probably want to be able to print out all the errors, right? So let's have that as well. I know I'm adding everything to the header file right now. I will just move stuff around later, but print errors. There we go. Right, I forget. Just output string, right? Yeah. Honestly, if no errors happen, then we don't print anything. So, right. I was about to print, print out saying, "Oh, no errors," but it's like, yeah, we know. If you don't print anything, then there were no errors. It's fine. Silence is golden, right? Right, and then we essentially just want to go through the list. So for, there's two ways of doing this. I could either just go and traverse the tree, going from, first to last, or from, yeah, I have to go from first to last. I could actually also simplify this a little bit by doing them backwards. But nah, let's leave it like this for now. It's fine. I kind of want the errors in sequence, not the other way around. Okay, so we want write error string, right? Actually, where is the... oh man, come on. This one, write source file error. Because this is essentially what I want. This is the file name, line, column, byte. And then an error. Later on I can add like different types of reporting. So is it an error message? Is it an info message or whatever? At the moment, let's just make everything an error. And instead of file, right. Okay. Error entry. Current. first, right? Damn it. Right, and this is current message. And then we get the next, and then while current, just do that. I think that works, right? So we're getting the first error entry as the current one. We're formatting like the strings, so we have the actual line numbers and stuff that we print out, and error, and then we just print out the error message prefix, which is this one, and then we print out the current error message, right? I don't want to add the error message into this formatting as well, because then I would have the message twice in memory. That seems kind of wasteful. I really just want to clubber up the prefix and then just basically two write calls, which is fine. And then we go to, no, oh, sorry, not G error list. No, what we want is, we want current next, right? Is the current. And if next at any point is 0, then we just don't do this. That should be right. Famous last words. Okay, put this in the C file, right? And then just take what we need here. So we need this one, right? And init global. Whoops. All right. Plonk that in here. And this G error list actually can also be in the C file. I mean, it doesn't really matter because, you know, it's all in one compilation unit anyways. I mean, you could be nice and do static here in case you want to use it in multiple compilation units, but I don't care about this, so it is what it is. Okay. Init, add, and print. Okay, so for add, I now can have convenience macros, right? Because passing all this is kind of nonsense, right? So add file error, right? So now we can actually sort of brain start working. Can sort of do this here, right? Write source file error. So instead of using this, Yeah. Yeah, okay, that's fine. So we have a source file pointer, right? And oh, but I don't know how to do macros with formatting. Oh no, I've never done that. How does that work? C macros var args. Okay. Is that actually in the C standard or was that compiler specific? Uh-oh. Wait, does it even search the whole document? Yeah, okay, it does. No. What did it say? It said something like, oh, this is GCC. Okay, let's see if something like this exists in the C standard at all, or if this is compiler specific. And then I can try and figure out if the Visual C compiler has something similar. Brain, sorry. Okay. Ah. Will you look at that? It is C standard. Nice. Okay, so I can just say add file error, add source file error, right? We have a source file pointer. We have I say format, I guess, and then dot dot dot, and then we just call add error, and we need the just call it file pointer, right? I don't want to type that much. File name. Okay, let's close this. It's getting annoying. File name. We have line, column, position, and then we just pass in the format. And then here, what was it? This one. And we can do the same for tokens, right? Because tokens also have this kind of information available, like the line and column. They don't have the file name. Okay, I have to think about tokens. I mean, we don't have token errors yet, so it's fine. That will come later with the parsing. I might have to extend the token to also hold the file name. I mean, it's just a pointer and an account, right? So it's not that much more data. It's fine. Okay, so if I build, right, exit code undeclared identifier. Okay, why is that? Right. Yeah, that will happen. Wait, is it U32? I forgot. Yeah, it is U32. Same here. That's it, I think. Yeah. Okay, cool. That is fine. And now I can actually remove this write source file error right here. Right, this is no longer of concern to us. And then let's see where I used it. What? Nowhere? Oh yeah, never mind, because I changed the code, didn't I? All right. Anyways, so now in stats, we don't have any errors here, right? But in token, do we have errors there? No, we do not. Okay, so only in source file. At the moment, at least. I mean, there's some errors here, but let's not worry about those for now. Code point new line, white space digit, and valid do not have that, but get code point. There we go, add error to global error list. Okay, so now we can say add source file error, right? And that would be the file. And then invalids. Do we want to print out that byte? Sure, we can, I suppose. Byte. You can print in hex, right? How does that work again? Just X. Okay. This is a truncated UTF-8 sequence. Do not need to say anything else to that. Also, I think I have to add new lines because I didn't think of that. It's a bit annoying, but maybe I can adjust that later. But it's fine. Okay, and then invalid UTF-8 continuation. And then down here, Invalid code point. Yeah, sure. As hex. Yeah, let's print it as hex. Okay, cool. So now I have added errors, but kind of hard to, you know, make these errors happen. No, actually, I could make them happen with an hex editor. Yeah, I'll make it happen in a second. Let's just make sure we're actually initializing the whole error list and stuff like that. So for that, we have init global error list, right? So this is the only thing we need to call, and we're going to call that in main.c right after we allocate the program memory arena. Or we could actually allocate that before and then just print out an error over that list. I don't know, but actually it might not be a bad idea. But for now, let's just init global error list, right? Okay, what is this? This looks like a macro issue again. What? Oh, is it because it's empty? Oh, that scared me. That is my 1 hour alarm. So I have 1 hour left, more or less. Okay, I'm a bit stumped right now. This is something I have not used a lot, so I don't know how to use it. That's the problem. But this is not using format at all. So do I not need format? Can I just... Okay, hang on. We're learning C, ladies and gentlemen. Can I just leave out format and just do this? Nice. Interesting. Kind of cool. I definitely did not know that. So that is just an argument list and whatever you use, and then it basically from that point on in the function, it just puts that stuff in as arguments. Okay. Nice. Okay. Cool. So we can still run and... Oh, print errors at the end. I did not do that, did I? Does error printing... Ah. Right. So let's do... stop parsing status. stop parsing stats, right? Because we do not want the timer to continue. And then we want to say print errors. And then we want to print the stats. Yeah. And we do not have any errors at the moment, so that's why we don't show anything. But let's just add an error. Just to see what would happen, right? Actually, I want to add 2 errors. Just to make sure I actually did stuff right. All right, so file name. Some file, right? 1, 2, 3. Hello. 42. Fantastic. What an amazing error message. And then we have a second error, some other file, right? 5, 6, 7. Hello again, but this time 99. No, let's do 42 again, whatever. Okay, build. Heh. Too few arguments. Line. Wait, file name. Yep. Line. Yep. Column. Yep. Position. Yep. Format. Yup. And then some other stuff. What? Are you worried about this? Yeah, you will. Okay. Fine. Okay. So we definitely have the errors right here. Some file, right? Line 1, column 2, byte 3, error, hello 42, and then some other file, error, hello again 42. So that works. Nice. So we can actually remove that from the to-do as well. So we have a global error list. Think about token buffers again. I have not really thought about it, and I probably need a bit more time than just 1 hour at the moment to just continue with this. So maybe I'm gonna quit early today, which my dog is probably excited about. Means we can go on a walk earlier. Actually, I want to make sure if I use X that it actually will display as a hexadecimal. And it does. Okay, cool. That's neat. So maybe I should make this in the... So in my assembly language, the $sign means hexadecimal. So I'm just gonna add that here as well. So if you use that tool, you kind of know what's going on, that this is a hexadecimal. Can I use capital X? I think capital X works, right? Where's program? There we go. Build, run. Yeah, cool. So in case you're wondering, I'm not freeing anything, right? Because the error list like does not need to be freed. In general, after the process terminates, so after this tool ends, everything will be freed anyways by the operating system, right? There's no chance Windows is holding on to reserved address space for you or anything like that if the process dies. Once the process dies, everything gets closed. File handles, all the reserved memory that you had or the committed memory gets freed for other things to use. So everything will be removed anyways. And that is even if a process dies unexpectedly, right? Windows makes sure it does the right thing here. It needs to. Otherwise, a rogue program could just crash the entire operating system at some point, right? That's not what you want. So I'm not bothering with freeing anything here because first, the global arena allocator that I'm using, where I'm just dumping stuff in, as well as the error allocator, they just live throughout the whole lifetime of the program anyways. So there's no point in freeing anything. It's just the list that grows and grows and grows, right? So yeah. What's all this? This is like a tokenizer thing. I definitely no longer need this. I can just delete that code, right? I'll definitely like how small the tokenizers are now. That is really neat. Oh, this is a U32 now. Okay. Let's have a look at the original one, the original assembler that I coded. So in case you haven't been here the previous stream, I actually already have an assembler that sort of works. It's just very messy code, and it's using the C runtime, so the standard libraries in some instances. And it's just, when I was basically starting out learning C, I did this as a project, which was, yeah. Ugh. And it's not feature complete by any means, but it is able to produce binary files, right? So this, it can actually take this program and make a fully functioning program out of there that you can run. I mean, I can show you in, where is it? Micro, Sublime, GameBoy. So here, I have a copy of this GBASM file right here, right? And this is the ROM that my old assembler created out of it. And if I just start Visual Boy Advance, great, there's an update. Open Game Boy. There we go. Program. There you go. It is actually a valid program that is able to run. Right? It's just Hello World, but it does run. So I had this version right here, and I basically want to rewrite it. I no longer want to use Visual Studio for all my projects. I have like this setup right here, which I really like, with the bat files and stuff like that. And Visual Studio just annoys me, so I just wanted to go away from it. And I'm basically taking all of these things that I did here and sort of translate them over to not use the C runtime, and then obviously to clean up the code, and also use arena allocators, which I only recently learned about, and I kind of find them really useful and cool to use. This here is using like heap alloc all over the place, which is just a ginormous mess, right? Also, error handling is like really poor, and like it's awful. It's awful. I actually wanted to continue with this one and actually extend it feature-wise, but then I looked at the code and was just like, nah, I can't deal with this, right? So, because it has been a while since I touched it. Yeah, so I started with the token file here, so the GBA token file, and translated it over to, you know, to actually do the thing it needs to do. And this is the result of it. As you can see, it functionally exactly the same thing, right? Went from 429 lines to 139. So, yeah, much cleaner to read, much easier to reason about, and yeah. Also, GBA files. So this file right here is basically now the source file thing. That definitely has grown a bit. But yeah, I mean, I moved some stuff around, so probably not fair to say that the token file got smaller because I just added some stuff to the source file, so it probably balances itself out. I don't know. So I've translated this over, and now we can basically have a look on what to do next. GBA parser is like the whole parsing of the tokens into the actual binary, and this file is just, I mean, it's 2,700 lines long, right? The size is not necessarily the problem. Like, I don't mind files being that long, but the code is just, yeah. I mean, you sort of look at this sometimes and you're like, huh? What was I thinking, right? And then I have all these return statements for true and false of whether when an error happened or not, and I like to get rid of that as well, as you saw. That's why we did the global error list, which this one doesn't have. It just printed out errors as they happened, and yeah. There is the ROM. I think this is like writing into the ROM, into the output. So we could probably think about that next. Although So actually, the thing that I really need to translate over, and this will be quite fun, is the hash map, right? So I had to do my own hash map implementation in C because C doesn't have hash maps out of the box, right? And I'm basically using this as a symbols table. So this is like the whole hash map stuff. This one was fixed size. It couldn't grow, and I would like to change that to be actually growable. So we're not constrained by some arbitrary size that I select, right? If someone wants to have 1,000,000 labels in their code, they should be able to use 1,000,000 labels, right? Who am I to say no? So if the machine can handle it, why not? So these are all the symbols. It's all the keywords that the assembler can use. So all the instructions and stuff like that. There's aliasing, so you could actually, I think I've done that in this stuff here. So you can have an alias, for example, for this number, you can just write this text, right? Basically like a define in C sort of thing. But I have not thought too much about how to, oh yeah, here are all the keywords. Look at that. Just putting it into the hash maps, into these slots. And I have made an define for the slot calculation to then, print me out this code so I can just copy paste it in here. It's great stuff. So yeah, I've not thought about too much on how to change this. What a nice way to do this would be for the hash map. I definitely want to use arena allocators for the symbols table as well. And since it's global, will be quite interesting to see how we can deal with that. Not quite sure, to be honest. It might maybe just use 2 arenas. Because I really want these entries to be in sequence, right? So I can just index into them. for the hash map. I mean, that's the whole reason for a hash map. So I might end up having one arena just for the actually hash table, and then put all the entries just on the global arena, because that's sort of my dumping ground for everything, right? And these entries don't really change. So this hash map is also quite simple. You never need to remove stuff from it, because why would you? After a symbol is defined in your code, you just want to hold on to it until all the parsing is done, right? So there's no actually need to remove anything of the table. Yeah. I'm probably going to do that next. Not right now, but Monday is the next stream, right? So I'm going to be doing that. Let's just make a to-do for this. I mean, think about this, yeah, but also... sorry. Implement symbols table / hash map with arenas. Arenas. Oh my lord. I hope you didn't hear that. That was my stomach. It appears I'm hungry. So maybe good thing I'm actually quitting now. I don't think there were any errors. I mean, we fixed a few errors from last stream, so that is good. Maybe also... implement basic command line options for input and output files, so we can just specify an input and output file with command line arguments, as opposed to having it hard-coded at the moment to this specific file right here, right? I mean, I have this to do right here, so... I'm sure I come up with something. I will be putting the source code for Alpha 2, if you want to. I'll be putting that up for monthly subscribers on the Ko-fi page. If anyone wants to check it out, it would be very nice. But other than that, I guess I see you guys on Monday. Unless there's any questions. If anyone has any questions, I'll give you a minute or two to type them out. And as soon as I ask for questions, viewers disappear. Sorry, I didn't want to put you on the spot. How come it says this is not used when it's actually used? Like, it is right here. What? Oh, I'm in the wrong project. Holy shit. Yeah, there we go. That's more like it. Okay, well, if there's no questions, I'm gonna end it here then. Next scheduled stream is Monday. So have a good week and weekend, and see you then. Bye.